The EcoHornet granular biomass heating systems open a new era in the production of heating energy using pellets. Completely different from other existing products, this new generation of heating systems, manufactured by EcoHornet, revolutionizes the concept of granular heating fuel, based on our own invention. This invention, registered under patent number A2008/00996, consists of a burner design that is entirely different from the already existing ones, namely a gravitational burner, as well as of a new combustion process of granular biomass pellets, adapted to this type of burner. The implementation of the new gravitational burner and of the new combustion process in the EcoHornet heating systems led to products that provide the users with real benefits. EcoHornet heating systems burn fuel completely, including ash particles and the smoke resulted from combustion gases, providing improved recovery of heating energy with a combustion efficiency of 98%. This higher efficiency of the EcoHornet heating systems of up to 90% lowers fuel consumption and considerably reduces heating bills. Due to complete fuel combustion, there are no creosote deposits on the walls of the burner and on the heat exchanger. Thus, the user is not required to periodically clean the appliance. Moreover, the pellet-based heating systems manufactured by EcoHornet do not require a chimney. Instead, they only require a burnt gas exhaust, just like gas-based heating systems, because the burnt gases do not contain smoke and ash particles. The EcoHornet products target all areas of activity, producing heating agent for both home users and for large spaces, such as industrial spaces, greenhouses, gymnasiums, swimming pools, churches, hotels, schools, etc. The EcoHornet heating system consists primarily of the following: pellet bunker, worm gear, feeding tube, combustion chamber, horizontal heat exchanger and ash bin, vertical heat exchanger, exhaust, gas exhaust tube, command panel. The pellets used for fuel fit into a bunker whose capacity ensures the operation of the heating system for a minimum of 48 hours at maximum power. Depending on the available space, the bunker's capacity can be increased for a significant increase in operating autonomy. The bunker of the heating system can be connected to a high-capacity tank, located outside the area of the heating system. In this case, the feeding of pellets can be mechanized. When constructing this external tank, the user must bear in mind the fact that the pellets must be kept dry. The supply of the central bunker from the external tank is made automatically, the commands being transmitted by a capacity sensor. When the power button of the heating system is pressed, the worm gear is set in motion, and the burner is filled with pellets. From the bunker, the pellets are taken over by a worm device operated by a 24-volt DC motor, heat protected. Thermal protection is a must in order to avoid the destruction of the gear mechanism, in case very moist pellets are introduced in the bunker or pieces of wood or metal have reached the bunker either from the pellets or during resupply. The pellet level in the combustion chamber is measured by means of a level sensor that maintains a constant level of fuel above the grate and that keeps a pellet-free area at the level of the supply tube, thus preventing the flame from spreading to the worm gear and to the bunker. The level sensor is protected both by placing it on a flame-retardant wall made of glass textilite and by placing a temperature sensor that interrupts the feeding process when a temperature of 60 degrees Celsius has been reached on the metal surface of the pipe. When the combustion chamber is loaded, the sensor stops the pellet supply, and the combustion resistor with a voltage of 24 volts is automatically activated. The resistor instantly reaches a temperature of 800 to 850 degrees Celsius, it is covered with pellets that ignite, and the exhaust starts to function. It provides air for combustion and the pellets ignite. At this time, the exhaust tubes take over the white-grayish gases, which do not form deposits on the walls of the heat exchanger. After the initial ignition in the resistor area, the fire will expand to all the grates within 5 minutes at the most. The combustion process continues until the room thermostat, which is part of the automation system, gives the command to stop the heating system, when the space where it has been placed has reached the desired temperature. The resupply of the combustion chamber with pellets is performed several times until the ambient thermostat registers that the set temperature has been reached and stops the pellet resupply. The pellets in the burner are ignited and burned completely, and the burning stops until a new supply and ignition command is given by the ambient thermostat. The on-off operation of the heating system, as controlled by the room temperature set using the ambient thermostat, is the most efficient operation mode. The burner is formed of 3 grates, 2 of which ensure constant circulation for the combustion of 6 mm pellets, and the third holds the incandescent pellets until their diameter is reduced below 3 mm. It also helps to increase combustion efficiency and reduces the amount of ash. The grates are made of heat-proof stainless steel. Some areas of the combustion chamber are made of the same material, while other areas are made of austenitic stainless steel. The combustion chamber enclosure is insulated with ceramic wool plates. The smokeless combustion without creosote deposits is possible due to an adequate distribution and dosing of combustion air and of secondary air. The building model of the gravitational burner, as well as the distribution pattern of the combustion air, ensure the combustion of the fuel and of the ash and creosote particles of the combustion gases. The automation ensures a constant air volume and combustion dynamics in order to achieve a complete combustion of fuel and high efficiency. The heat exchanger is made of steel, according to EN 303-5/1999, and has 2 distinct areas. A horizontal cylinder with double walls which circulates the heating agent, heated by radiation from the flame, and a vertical cylinder area in association with a horizontal area, which houses a number of pipes for burned gas called the convection area. Metallic spirals are inserted in the tubes for vortex generation and gas routing. Another area was designed above the pipes of the convection area of the heat exchanger, which provides both the uniform absorption of the gases through the pipes, as well as a reduction of their speed, which allows the ash microparticles involved to deposit, stop, and then gravitationally return through the pipes in the ash bin. The horizontal cylinder also functions as an ash bin. In the area below the burner, there is a door designed for the disposal of ash. The ash is disposed of every 30 days of operation for the heating system. The burnt gas temperature in the exhaust circuit varies. It reaches 1000 to 1150 degrees Celsius at its exit from the burner, 400 to 450 degrees Celsius upon entry in the convection area, and 120 to 170 degrees Celsius upon its release into the atmosphere. The surface of the outgoing pipe for the heating agent is provided with a temperature thermocouple, providing information which is retrieved and processed by the automation system. The heat exchanger is heat insulated with aluminized mineral wool and is placed in a metallic or fiberglass housing, whose outer surface temperature does not exceed 35 degrees Celsius. Unlike other pellet-based heating systems on the market, EcoHornet heating systems do not require burner or nozzle cleaning devices in operations, since the burned gases do not contain any smoke. EcoHornet heating systems are extremely safe when in operation, the entire combustion and supply process being perfectly controlled and supervised by the automation system. In addition, to prevent overheating of the thermal agent, the automation system includes a UPS unit to keep the fan and the recirculation pump operational until full combustion of the fuel is achieved. The EcoHornet heating systems have powers ranging from 15 to 80 kilowatts, representing the latest technology for pellet-based heat generation, providing users with comfort and ease of use, constant high efficiency, lower fuel consumption, and maximum safety. By applying our own invention, gravitational burner and combustion of pellets of granular biomass, we have made possible the efficient and environmentally friendly heating of large spaces such as industrial spaces, warehouses, gymnasiums, churches, exhibition complexes, and the such. Hornet Group makes ahead of anyone worldwide pellet-based burners using radiant tubes. The lack of ash particles and of smoke from the burned gases and the temperature at which combustion is achieved ensure the transmission of heat from burning pellets through radiant tubes, maintaining the operating parameters constant without needing to be cleaned. The radiant tube burner system manufactured by Eco-Hornet consists primarily of the following: pellet bunker, worm gear, feeding tube, combustion chamber, insulated tube for the circulation of burned gas, radiant tube with projector, exhaust. The size of the burner and the dosing method for combustion air and secondary air allow the users to control the temperatures required for the optimal operation of the radiant tubes. The pellet combustion temperature of 1000 to 1150 degrees Celsius is reduced by dosing secondary air, and upon entry of the burned gases into the insulated routing tube, their temperature does not exceed 800 degrees Celsius. Upon reaching the radiant tube, it is of 650 degrees Celsius, and it reaches no more than 250 degrees Celsius at the level of the exhaust system. The distribution of temperatures in the radiant tube between 650 and 250 degrees Celsius ensures the uniform heating of the space in which it was located by infrared radiation sent to the ground by the projector located above the heated tubes. The power of the radiant tube burners manufactured by Eco-Hornet ranges between 20 and 60 kilowatts, with U-shaped linear tubes with a length of 4 to 12 meters, or with linear tubes with total lengths between 8 and 24 meters. Radiant tube heating is extremely efficient for large areas, achieving heating identical with that provided by sunlight, without using large volumes of air. Eco-Hornet pellet burners for radiant tubes provide major consumers with a cheap, clean, and efficient heating system.